Earth, our blue planet. As far as we know, the only place in the universe with intelligent life. Life for which water is indispensable. But not all places on Earth are blue. Large parts, such as here on the Arabian Peninsula, are yellow, desert, where hardly anything can live. Human beings do not, however, give up easily. Through inventiveness and technical expertise, people are capable of transforming even the hottest and driest places on Earth into a blooming environment, and prosperous places where it is good to spend time. Where water is needed, water is brought in. As here in Abu Dhabi, every tree and every bush is meticulously watered. In this way, it is not just possible for people to live in the desert, but the desert as a whole becomes livable, changing into a great oasis of greenery. Abu Dhabi, the capital of the United Arab Emirates, is expanding ever more rapidly. But more people also need more water. Fresh water that has to be transported over ever greater distances. In 2008, the Abu Dhabi Transmission and Dispatch Company, Transco, commissioned the engineering and construction firm Lindenberg to lay a new drinking water pipeline.
Actually, this is the general layout of our project. The purpose of the project is to water supply, drinking water supply to the new developed island through a main trunk pipeline 64-inch to supply 76 million gallons per day drinking water. This is the tie-in connection. The red color is our pipeline 64-inch. The blue color is our pipeline bi-directional drilling method, which is twin line 48-inch carbon steel pipeline. The water is coming from the desalination plant, which is far away around 30 kilometers from the connection point.
The whole project was engineered by the firm Tebodin. For the construction of the water pipeline in the seabed between the four islands, it was decided to use a horizontal drilling technique. This is no easy assignment. So a firm was sought that had already earned its spurs internationally in this area. A firm with drilling experience in all types of soil strata was quickly found.
Flowtex Egypt, hello, good morning, how can I help you?
Flowtex Egypt, a company that has built up a big name, with over 60 borings beneath the Suez Canal. A drilling company with its headquarters in Cairo that works with specialized professionals from all over the world.
Lindenberg and Tebodin and Transco choose Flowtex first because they know that Flowtex did big projects in Egypt and outside Egypt, like Azerbaijan, like Madagascar, like Saudi Arabia, like Syria, in Abu Dhabi as well before. And they believe as well in our capacity, our equipment and personnel. That's why they chose Flowtex to do this big projects.
You know, we have a good crew. Flowtex now, you know, it's like the biggest company in the Middle East. We make it more crossing, you know, big crossing in Saudi Arabia, in Azerbaijan, in Sudan, yeah, and a lot of crossing in Egypt.
So, Flowtex is the right company to handle the drillings in Abu Dhabi. After various preliminary talks, an engineering, procurement and construction contract has been signed.
We can say the HDD work is between Lindenberg and Flowtex. Let us start for the geotechnical investigation. Lindenberg did the geotechnical investigation for each crossing. And after that, Flowtex, they are doing the engineering, design and calculation for each crossing and the drilling also.
The diameter of the new pipeline is 64 inches, but such a big hole has never been drilled before. It is therefore decided to construct two pipelines, each 48 inches in diameter. A valve chamber enables the two somewhat narrower pipelines to be connected up to the big pipeline.
Well, the difficulty on this project is that we're talking about two 48-inch pipelines, so big diameter pipelines. The problem is the width of the corridor. There was only a 5-meter wide corridor available. So that's why we have to install the pipelines on two different elevations. The top elevation is a short crossing, and the deeper one makes the crossing 100 meters longer. and the pilot drilling has to be very accurate and is quite difficult under these conditions.
It is therefore very important to know the precise composition of the soil to be drilled in. This is done by means of core drillings and laboratory analysis.
We are getting sand, shelly sand. After that we start getting calcarenite rock. It is rock maybe 8 meter, 9 meter calcarenite, 10 meter calcarenite rock. Then after that it is in Abu Dhabi in general we are getting siltstone and gypsum.
Once the seabed has been charted, the preparations can begin.
Flowtex is also responsible for the engineering. We have to provide the calculations showing the wall thickness of the pipe and all the stresses in the pipe during the installation of this product pipe.
While the pipes are being welded together above ground, we proceed to the first of the 4 drilling locations, Al Fahad Island to Jubail Island. 2 pipelines with lengths of 1,610 and 1,730 meters. Here, the Flowtex workers have now set up the site. The drilling rig has been positioned, ready for the first drilling. But how does HDD work in practice?
I'm helping Flowtex with the design of the projects, and then I'll set out the land surveying, set up the job, the land surveying of the coils, the mathematical calculations. As we drill, I'll take surveys and recalculate our position and give the driller targets to drill from A to B.
The first drill pipe, which will enter the ground, is equipped with a drill head. Inside the drill head, there is a magnetic steering tool with a cable that runs through the drill pipe to the computer, giving real-time data from the steering tool. Parallel to the new pilot hole trajectory, a 6-inch plastic pipe for fiber optic cable was pulled in. Because it was not used at that moment, a 6mm electric cable connected to the computer was installed inside the pipe, building a coil. By putting power through that coil, a magnetic field was created. So, during drilling, readings can be taken from the cable as well.
The data from the steering tool gets transmitted through the cable, which is inside the drill pipe, and it comes into the interface, and then that data comes to the computer. And on here we can see the inclination, which is the angle in the vertical, and we can see the azimuth, which is the angle in the horizontal plane. When we take a reading, the computer recalculates our position for every drill pipe using these angles.
This is this for rotation, this joystick for rotation, okay? And if you put it here, you make a right rotation. If you go this way, you have left rotation, okay? And this is joystick right side. If you push here, this is forward pushing. If you go back, this is pulling. This is for this gauge for steering tools, okay? It's this data coming from the drilling head in the front. You see, now I rotate. This is the high side, this is the bend, this is the angle bend, okay?
After the last calculations and preparations, the drilling head is placed in the correct starting position. And then, the moment has come. The drilling head slips slowly into the ground on the way to drilling its first hole in the virgin soil. A clay-like drilling fluid is pumped through the drill pipes under high pressure, through jets in the drill head. The jetting force of the slurry erodes the soft soil, creating an exact trajectory in the ground. The drilling fluid transports the eroded soil particles out of the borehole and supports the drilled hole. Meter by full meter, the pilot drill traces out a path along the projected route. Continuous checks and adjustments are performed. The composition of this drilling fluid is therefore of critical importance. Each type of soil or formation calls for a particular kind of composition. Samples are taken with great regularity in order to check whether the slurry meets the requirements. Bentonite, an important part of the drilling fluid, is, it should be noted, environmentally inert. It is as far as possible recaptured and pumped back for recycling and reuse on site. clamped in the breakout unit, the pilot pipe is slowly pushed downwards. Once the pipe has reached the bottom of the rig, drilling stops and the pipe is fixed in position and a new pipe is inserted. But before the new pipe can be coupled to the previous one, the steering tool data cable must be installed and connected. Once this has been done, the two pipes are screwed together and the drilling can continue. In the meantime, preparations have also been completed at the second location, between Sadiat Island and Jubail Island. Here too, the drilling for a 692 and a 763 meter pipeline can begin. On this location, the future water pipeline is situated immediately beside the E11 10-lane wide highway. To maintain the integrity of the road foundation, a retaining wall made out of steel sheet piles has been installed. Nothing is left to chance. Back to the first location. The big moment has arrived. The pilot drill has reached its destination. If the guidance engineer and the driller have done their work properly, the drilling head should emerge from the sand at the place marked beforehand. Always a tense moment. The connection has been made, but the hole with the diameter of the drilling bit is far too small. With the aid of reamers, the borehole is enlarged in steps until it is big enough to take the lengthy string of 48-inch product pipe, in this case a hole of 72 inches. The pipe with the drilling head is therefore disconnected and replaced by a set of 3 reamers that is pulled back through the borehole. Behind the reamers is another string of drill pipe so that the link between both ends of the drilling trajectory remains. The reamers are pulled back to the rig side. At the rig side, the pipes are disconnected one by one, pressure washed and stored for subsequent use. At the same time, their counterparts at the pipe end are connected up again with the aid of a pipe tongue. The connection between both sides of the water remains in place. After some time, the reamers reach the rig end. Here, everyone waits anxiously for the reamers to emerge above ground. And once the first reamer ultimately emerges from the drilling fluid bath, there is a sudden flurry of activity. The construction site has to be cleared and parts disconnected, pressure washed and hoisted clear. Without disruption to traffic or shipping, Flowtex is helping with the construction of a new water pipeline in Abu Dhabi. Meanwhile, the steel pipes are being welded together in various places on the 4 islands to form a pipe string of the right length. This is a painstaking task that can only be performed by qualified professionals. In order to be sure of good quality, each welding seam is ultrasound investigated, a joint field coating is then applied, and the pipe string is hydrostatic pressure tested. The pipe string is ready, and after a number of reaming and cleaning steps, the diameter of the borehole is big enough. The lengthy water pipeline can be pulled through the hole. To be on the safe side, a reamer is attached in front of the pipe in order to eliminate any remaining irregularities in the borehole. At this point too, safety, of course, comes first. Particularly at such an exciting moment, this must not be lost sight of. As the long water pipeline must go into the ground at precisely the right angle, the strand is suspended on mobile rollers supported by side booms. Once a final check has been made, the pullback process can commence. While the reamer is spraying drilling fluid, the entire pipe string, followed with the closest attention by everyone involved in the project, is in motion. Gradually, the pipe disappears through the drilling fluid pit below the ground into the borehole. The entire pipe string is hoisted up beforehand on rollers. This allows the long pipeline to be pulled into the borehole with minimum force. The borehole is filled with drilling fluid, which threatens to push the empty pipe upwards through its own buoyancy. But a solution has been devised in advance for this problem too, by filling the pipe with water with a mobile hose. A special basin filled with drinking water has been constructed for that purpose. While the long water pipeline is pulled through the hole, the water hose is drawn along with it, while the rollers that have come free are removed. At the rig end, the drill pipes are disconnected one by one. This goes on without interruption for 15 hours. And then, by which time it is the middle of the night, everyone at the rig side is in a state of great excitement. Will the pipe emerge from the ground as expected? The final pipes are disconnected. All of a sudden, the reamer emerges from the drilling fluid bath. And then the moment has come. The water pipeline itself is drawn up to the surface. Great celebrations among all those present. The first of the 8 pipelines has been successfully drawn through below the water. A skillful piece of work and a historic moment, which even the CEO of Flowtex Egypt, Mr. Mohammed Sada, has travelled to Abu Dhabi to witness. The next day, when the product pipe string has been disconnected, both product pipes are ready to be connected up to the valve chamber. We are now on the way to the third location on the Yas Island. Here, the preparations for the drilling of 2 more pipelines, 1,258 and 1,278 meters long, are in full swing. This time, the pipeline will run beneath a canal. When we arrive, sheet piling is just being installed where the drilling rig is to be positioned and fixed against push and pull forces. A couple of weeks later, preparations are being made at the second location for another pipe string to be pulled back through the borehole. The long pipeline is already in position on the rollers and the reamer is also being prepared. But before coupling it to the drill pipe string, the Flowtex crew places 6 extra heavy pipes in position in order to absorb the high forces. It is already late in the evening when at last the pipeline of no less than 1,730 meters in length can be connected securely to the drill string. The actual pullback process will have to wait until the next morning. Early in the morning, with the sun barely up, the work can start. Once again, the pipeline gradually disappears into the borehole via a drilling fluid reservoir. This is the second 48-inch pipe at this drilling location. The first is higher up and therefore a little shorter than the second. It is clearly visible how close together the 2 pipes are. Flowtex spares neither cost nor effort in order to assure the quality of its work. In Abu Dhabi, the company makes use of the knowledge and experience of an internationally renowned specialist.
So I've been called in by company Flowtex to improve the quality on this project because it's a very sensitive water project in Abu Dhabi, and Flowtex didn't want to miss any chance to ensure the right quality. And so we double-checked all the procedures in the planning and execution phase, and now we have a very high standard of quality. And this is a reward for the whole team because the pull force is very low, which is an indication that it's a perfect borehole and a perfect quality.
Late the same afternoon, the pipeline, once again preceded by the reamer, emerges at the rig side. An additional difficulty arises. Since the pipe is at a lower level than the first pipe, the reamer cannot be detached with a separate breakout unit. The level of the drilling fluid reservoir therefore needs to be lowered first. Once the pipe emerges above ground, people can breathe freely again. This water pipeline too lies in exactly the right place. Not until the last product pipe has been installed is the entire drilling project successfully completed. Therefore, we head for the fourth drilling location, between Yas Island and Fahad Island. Here, two pipelines, one of 640 and one of 602 meters, have to be pulled in. This drilling location is right beside the famous Abu Dhabi Formula One circuit, the Yas Marina circuit with the adjacent Ferrari World Amusement Park. This creates its own problems. The location is closer to the city and therefore there are all sorts of electricity cables in the ground. For safety and protection of the high voltage cables, before drilling, a number of heavy concrete plates are first placed in position. Because of the weak soil on the rig site, for the first 100 meters, a so-called casing pipe has been installed before the actual drilling could start. While drilling continues apace in various places, the main contractor, Lindenberg, is busy connecting up the pipelines that are now ready to the mains.
So we are here in this point. This is the exit point of submarine crossing between these two islands. We are here exactly. And this is the concrete chamber for the fiber optic cable. Also, as I explained, we pull two carbon steel pipeline 48-inch and HDPE pipeline for casing for fiber optic cable, which is going through our main trunk.
Since the natural environment in this part of the world is extremely fragile, the project is subject to strict environmental requirements. For this reason, operations are kept extremely clean. The drilling fluid pits, for example, are embanked, and the drilling fluid is recycled. But construction can also mean that something has to be sacrificed. In this case, a number of mangrove trees.
This is the area of mangrove trees. This is full of mangrove trees, and this is our pipeline. So our pipeline is constructed through the mangrove trees. We remove all the mangrove trees, as I explained, and we replant new mangrove trees in another area to replace all the damaged tree. This is a mangrove. This is our pipeline. You will see all the bond is constructed under the bond.
But the drilling continues. Right now it is the turn of the first 640-meter water pipeline beside the Formula One circuit. With the morning mist obscuring the view, here too the pipe ultimately disappears gradually below ground. As previously noted, the space in which drilling is possible is extremely limited on account of the numerous electricity cables. The size of the exit or entry pit has therefore been reduced to the minimum with the aid of sheet piling. One by one, the pipes are disconnected, and it's a matter of waiting for the new pipeline to surface. And problems? They are there to be solved. For the people of Flowtex Egypt, working in this environment has become almost routine. In this way, Flowtex, as a specialist in horizontal directional drilling, helps with the further development of Abu Dhabi, the new city in the desert, with water. For only then can it be a prosperous place that is pleasant to stay in for all concerned.
It was a big challenge, this project, the HDD work especially, it was a big challenge for us. And we did everything according to the specification, and as I said, we did crossing and we broke the worldwide record in terms of diameter and the length of the crossing.
8 HDD drillings with a borehole diameter of 72 inches for 48-inch pipelines in 4 locations. Drillings ranging in length from 600 to 1730 meters, 20 to 32 meters below sea level. In very difficult circumstances, particularly given the soil types, hard formation sections followed by extreme soft soil sections, and given the environmental requirements and the existing infrastructure.
Yeah, I think Flowtex is doing all right. We have solved our problems. We even received a new order to install 2 more 48-inch pipelines.
Flowtex Egypt, the HDD specialist, brought water into the desert.